Hi dear students, we discuss a new topic today, that is the Dirac delta function. Dirac is a great physicist who has contributed a lot in quantum mechanics, and first we discuss the one-dimensional Dirac delta function. Okay, actually the one-dimensional Dirac delta function, that is represented by delta x, that can be pictured as an infinitely high and infinitely narrow spike. That is, this is along x axis and x is equal to 0 position, and the Dirac delta function has infinitely high, that is infinitely high and infinitely narrow width. So this width is should be very narrow. Okay, this is our delta x. The width is dx, then the height into width integration delta x dx should be 1. Okay, width means this will be the width of the peak. That the infinity goes from minus, the limit goes from minus infinity to the plus infinity, delta x dx is equal to 1. Okay, this delta function is not a usual function. This delta function has a area that is equal to 1. Okay, this is the picture of the delta function, and if we denote the properties of this function, that is, if x is less than 0, then the delta function will be vanishes, that is 0. In the x greater than 0 region, the delta function can be written as 0. But that is means beyond this region, delta function is 0, and above this region also 0. What about at x? At x is equal to 0, the delta function goes to infinity. That is here. This function goes to this function goes to infinity at delta x is equal to 0 position. Okay, the another description, that is, the delta function has unit area under the function. That means minus infinity to infinity. The area means, here I have written height into width in the picture. Height into width. If you say this is height and this is the width, then this will be the area. Therefore, here I represent here minus infinity to plus infinity, delta x dx is equal to 1. That is, the delta function has unit area under the function. That is a function which follows all these 4 properties, 1, 2, 3 and 4. A function which follows all these 4 equations is called Dirac delta function. Then if I write collectively, I can write this delta function as delta x is equal to, that is equal to 0 when if x is not equal to 0, collecting these two, 1 and 2 statement. If x is less than 0, delta x is equal to 0. Delta x greater than 0, delta x is equal to 0. If you see the picture, it is very clear. If x is greater than 0 in the region, that function, that is this delta x is 0. And if less than 0 region, this region, here also there is no, our delta x function is equal to 0. then I can write at the third steps at x is equal to 0, delta x is equal to infinity. This delta x is equal to infinity if x is equal to 0. Together with the fourth equation, that is, and minus infinity to infinity delta x dx, the area of the delta function have unitary. Okay. Therefore, simply we can say this is the definition of the delta function. Technically, delta x is not a function at all because its value is not finite at x is equal to 0. At x is equal to 0, its value is infinite. Therefore, this is not a function, but in the mathematical literature, it is known as a generalized function or a distribution. It is generalized function or distribution. You can also represent a delta function. There are several representations for delta function. Here, I consider step function, and this is along the x-axis. This is the point at x is equal to 0, and the width of this step is a, and this is the point x is equal to minus a by 2. This is the point x is equal to plus a by 2. Okay, then according to the delta function, here if the width is a, then to get the area to equal to 1 unitary, that is, area should be width into height should be 1. If width is a, height should be 1 by a, then it will be equal to 1. Therefore, my height of the this step function, that should be 1 by a. This is a height. Then the function f of x is defined as, here function f of x is defined as at x less than minus a by 2. It means this region x less than a by 2. There is no step. That is, if this is a f of x, then f of x is equal to 0. Similarly, x greater than a by 2 region, here also the function does not appear. First function does not have any value. That is, x greater than a by 2 plus a by 2, function is equal to 0. But between these 2 points, that is between x equal to minus a by 2 and x is equal to a by plus a by 2, we can write this function as a particular value. That particular value is f of x is equal to this, f of x is equal to 1 by a. That is, I can write here minus a by 2, the value of x between minus a by 2 and a by 2, the function has a value 1 by a. Then what about at x is equal to a by 2? That is at this particular point. This is in the picture at x is equal to point represent x is equal to minus a by 2 point, where the function can have any value. any value means this can be at 1 by 2a. And similarly, if this is a 1 by 2a point, then x is equal to at a plus a by 2. At this position, this function has a value that is 1 by 2a. In this way, one can write this function. One can define that is at x is equal to minus a by 2 or at x is equal to plus a by 2, we can define any value. Any value that should be less than, that value should be less than 1 by a. ആണ് ഇതിന്റെ maximum height വരുന്നത്, അതിന്റെ width എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ that is 1 by a. Okay, that is at x is equal to minus a by 2, the function I can define as a 1 by 2a, and x is equal to plus a by 2, the function I can write 1 by 2a. Okay, fine. Thus, you can represent the delta function in the several ways. Okay, we can also shift the spike from x is equal to 0 to some other point, x is equal to a. In the earlier case, we had the spike at x is equal to 0, this delta function. I can shift this function to some other point, that is at x is equal to a. This here the point is a, and this is x-axis. This should be a narrow one, and this function is delta of x minus a. I have shifted from x to the point a. Our condition is this area should be, this area is always 1. Okay, then the delta function, that is a spike, this is a spike, the spike is shifted from the position x equal to 0 to the x is equal to a. Then I can write this delta function as delta x minus a is equal to, that I have a 0 value where x less than a, delta x minus a is equal to 0. Similarly, x greater than a, the delta x minus a is equal to 0. But at x is equal to a, this function has a infinite. Actually, ഞാൻ ഇവിടെ വരച്ചിരിക്കുന്നത് അത്ര ക്ലിയർ അല്ലെങ്കിൽ ഇതിങ്ങനെ ഇൻഫിനിറ്റിലേക്ക് പോകുന്ന രൂപത്തിലുള്ള ഒരു പിക്ചർ ആയിരിക്കണം. That is x at x is equal to a, our delta of here the function is delta x minus a, that should be infinity. Okay, that is collectively I can write here, if x is not equal to a, which means this represents these two conditions. Okay, these two conditions is represented by this single statement, and at x is equal to, if x is equal to a, the value of the direction function is infinite. Similarly, this area must be unitary. Therefore, with minus infinity to infinity, delta x minus a, that is a height, and the width, that is dx. If I say this is a width in the picture, dx, this height into width is equal to area, that should be 1. Okay, now there is a one property of this delta function. That property is very important. What is that property? That is, if f of x is an ordinary function, Then f of x is multiplied with delta x minus a, then what will be our answer? See, this will be, that is minus infinity to infinity. I am going to change this function, that is f of x delta x minus a dx, that will be equal to the fa. This property is very important because we will do a few problems based on this property. Here the integral is actually from minus infinity to plus infinity, but the integral need not run from minus infinity to plus infinity, but it is sufficient that the range of integration must cover the position where the function has the maximum value. That is, if you see this picture, that is this picture, the integration limit need not run from minus infinity to the plus infinity. That is at least, but it is sufficient that the range of the integration, one can start from this point to this point, x is equal to this point, x1, x is equal to this point. No need to start from the minus infinity to plus infinity. Only thing is that wherever the function is having the maximum value, that is the function is having maximum value at x is equal to a, then the range of the integration must cover the position where the function has the maximum value. That is the only criteria. Then one can use the integration limit from a lower limit x1 to a higher limit x2. Within this limit, this function has the maximum value. That is, let me note down. This is the conclusion. That is, the integral need not run from minus infinity to plus infinity, but it is sufficient that the range of integration must cover the position where the function has the maximum value. Now let us do a few problems based on this discussion, that is problems. Okay, let us do, this is the solved problem in the Griffiths textbook, that I would like to do this problem first here. That is, the given function is this one, 0 to 3 integration x cube delta x minus 2 dx. We have the identity. The identity is this one, minus infinity to infinity f of x delta x minus a dx. The answer of this one is f of a. Fine. Now, using this identity, how we will solve this problem? That is very simple. Here, if you see that our limit is from 0 to 3, then in the bracket, in the delta function, it is given delta of x minus 2. Then in the simpler fashion, if I write our equation, that is 0 to 3 x cube delta x minus 2 dx is equal to what? That is our question. Comparing these two equations, you can identify the few terms, that is f of x is nothing but x cube, f of x is equal to x cube, and a is equal to 2. Then, and the integration limit is from 0 to 3, okay, which means if you plot your x-axis here, this is 0, this is x-axis, this is 1, this is 2, this is 3, and you have to see where your spike is coming. Then to know the position of the spike, it is very clear if you take this is x minus 2, that is if x minus 2 is equal to 0, then this will give x is equal to 2. The spike should come at x is equal to 2. Okay, that is the of course this function gives that here the spike comes here. Okay. This x is equal to 2 exactly lies between the integration limit 0 and 3. That is this 0 and this 3. Fine. Therefore, if such a condition is okay, or if such a condition is valid, then the answer should be f of a. What will be the f of a? F of x, we have this quantity. F of a means here a is equal to 2. Then you substitute f of 2 is equal to 2 cube, that is answer is 8. Therefore, the final answer of this question is this one. Integration from 0 to 3, x cube delta x minus 2 dx is answer is 8. This is the answer. Before going to the next problem, one point I would like to stress here, that is the spike would remain inside the domain of the integration. That is the thing we have to check. That is exactly the spike here remains in the domain of the integration. That is the domain of the integration here is from 0 to 3. Okay, this is 0 to 3 is the domain of the integration. Our spike lies exactly in between these the limits. Okay. Then there no need to do anything. You just substitute the value of a, this f of a, in the given function. Here the value of a is equal to 2. Then you will arrive at the final answer. That is 2 cube means 8. If the upper limit had 1 instead of the 3, then we have to see the result of this integration. That is, if the question was this one, delta x minus 2 dx, then see the answer of this question. That is, we have to see where the spike comes. That is, put x minus 2 is equal to 0, then x is equal to 2. The spike appears at x is equal to 2. Then if I plot this one, this is a 0, this is 1, this is 2, this is 3, and according to this expression, the spike appears at x is equal to 2, that is here, but our limit is from 0 to 1 only. Within this integration domain, the spike does not appear, but the spike appears at x is equal to 2 only. Then this answer of this question is, that is equal to 0. That you have to be very careful. Now let us move to the next question. These questions are the unsolved questions in the Griffith textbook, and let us do the one by one. And then you will be very much experienced with these types of questions. Okay, here the first question is A, that is 2 to 6 integration 3x square minus 2x minus 1 into delta x minus 3 dx. Let us write our standard equation, that is minus infinity to infinity f of x into delta x minus a is equal to f of a. Here the function f of x, that is f of x is nothing but 3x square minus 2x minus 1. This is the function f of x. Before proceeding, first we had to check whether the delta function, the spike, where it appears, whether it is comes within the domain of this integration or not. Here the domain of the integration is 2 and 6, and the spike appears x minus 3 is equal to 0, therefore spike appears x is equal to 3. And if I draw the plot here, this is a 0, 1, 2, 3, 4, 5, 6. Okay, and this is x-axis. Our spike appears here at x is equal to 3 here. Then the integration limit, okay, the spike exactly comes within the domain of the integration, that is from 2 to 6. No need to worry. Now let us proceed. What will be the answer? Nothing to do, just find the value of a. Here the value of a is 3. Then f of a, because we have the f of x, the function. Once I will write one more step here. F of x, we have 3x square minus 2x minus 1. Then f of a means here f a is equal to 3. Then f of 3, that is equal to 3 into 3 square, instead of x substitute 3, minus 2 into 3 minus 1, that is 3 into 9 minus 6 minus 1, that is 27 minus 7, that is equal to 20. Now the answer of the first question is this is equal to 20. Now let us proceed the second question. In the second question, B, Dirac limit is 0 to 5 cos x delta x minus pi dx. Then here the write the standard equation, minus infinity infinity f of x delta x minus a dx is equal to f of a. Here also we have to check whether the spike comes within the domain of the integration. Then if you want to know the position of the spike, better you can write this x minus pi is equal to 0. This will give you x is equal to pi. X is equal to pi means pi is equal to 3.14. Then if you draw the axis here, this is 0, 1, 2, 3, 4, 5, because we have the limit up to 5. Integration limit നോക്കുകയാണെങ്കിൽ 0 to 5 വരെയുണ്ട്. Around 3.14 means here our spike appears. Fine. Now next what you can do, you can simply evaluate f of a in the function f of x. That is, here the f of x is nothing but this is your f of x. That is f of x, I can write cos x, then f of a. F of a means here a is nothing but our pi. If you compare these two equations, a is nothing but pi. Then f of pi is equal to cos pi is minus 1. Then the answer is f of a. What we have obtained here? F of a obtained here is minus 1. Therefore, the final result of this integration, that is second question, integration 0 to 5 cos x delta x minus pi dx is equal to minus 1. Okay. Now we have solved the second question also. What about the third question? If I write with the compare with the standard equation, okay, copy here first question C, 0 to 3 x cube delta x plus 1 dx, this is minus infinity to infinity f of x delta x minus a dx, that is f of a. Here if we compare f of x, that is nothing but x cube, and this a is nothing but 1. Okay. Then to know the exact position of the spike, that is you can equate this x minus a equal to 0. Okay, no, sorry. To know the exact position of the spike, you can equate x plus 1 to 0, x plus 1 equal to 0, x is equal to minus 1. Okay. Once you obtain the position of the spike, then you have to see whether the spike appears within the integration domains. Here the integration domain is 0 and 3 in this expression. Okay. But this x is equal to minus 1 lies outside the integration domain. Then if I draw the axis here, this is 0 minus 1, that lies here, 1 2 3. The domain, the spikes appears here, but the integration domain is between 0 and 3. Therefore, this answer is 0. Now, then you can write like this one: spike remains outside the domain of integral. Therefore, its answer is 0. 0 to 3 x cube delta x plus 1 dx is equal to 0. Now let us move to the next question. That is the question D. This is the question D. If you compare with the standard equation, that is minus infinity to infinity f of x delta x minus a dx is equal to fa, then first we have to check where the spike comes. You know that we have the delta x plus 2, that is x plus 2 equal to 0. This will give x is equal to minus 2. And the spike appears at the x is equal to minus 2. Then check whether the spike position comes within this integration domain. Integration domain is from minus infinity to plus infinity. Then if I draw the axis here, this is goes to plus infinity, and this is going to minus infinity. Roughly, x is equal to minus 2 comes well inside the integration domain. That is, spike comes well inside the within the integration domain. Now let us apply this equation. Okay. Here, if you compare these two equations, this is our f of x, and here if you compare these two, and this is the a, that is a is minus 2, because here we have minus sign. Okay. Now we have obtained f of x and a. Then I can write here f of x is equal to natural log of x plus 3. Then f of a is equal to natural log of a plus 3, but here a is equal to minus 2. Therefore minus 2 is equal to natural log of minus 2 plus 1. Minus 2 plus 3 is natural log of 1. Natural log of 1 means 0. Good. Then here the present case, the answer here is f of a we obtained. This f of minus 2 is equal to 0. Therefore the answer of this question is equal to 0. Okay. Thank you very much for watching this lecture.